The intent was to test out what we're calling a real world scenario, an application for NFV technology for our customers. And so we're engaged in a lot of real world customer activities right now, proofs of concepts and trials. And we're getting a lot of real good feedback from our customers around not only how they want the technology to work, but just as important, they want to really understand the business case for NFV, which is obviously important. And so we've seen some of these other benchmark tests happen. And what we've noticed is, wow, the results are actually very interesting, generate a lot of media buzz. You dig into the details, and it's a single VNF running on a 24 processor Xeon, box. I mean, that's a $10,000 box. In terms of real world requirements and real world scenarios, you can't necessarily deploy that type of configuration in, say, a VCPE type of use case. It's just too expensive. And so, we thought it would be really good to take the broader learnings that we've had from some of our customer activities, work in a more controlled third-party test environment, and see what kind of performance envelope that we got across a variety of different test configurations, but all in this kind of quote-unquote real-world scenario.
Got it.
And so, as you mentioned, we worked with a number of our ecosystem partners to do this test. We had a carrier sponsor that provided a number of requirements and validation of the testing, and just kind of, what are their expectations for these types of solutions in their real world environment. And that was by a company called Integra Telecom. And so they provided that feedback around the requirements. And then, we leveraged Intel as a partner for providing some of the, obviously the base underpinnings of technology, the core processing of the boxes that we use to run the tests, as well as their DPTK solution for getting accelerated data path in that type of low-cost operating environment. In the slides that we have, in the detailed information that was sent to you, we actually used Intel's Atom C2000 processor. So it's a little bit lower end processor than the Xeon. It was a dual quad-core box. It was strictly a white label box built by Supermicro to do the actual testing on. But again, it's a very low-cost solution in terms of those types of VCPE, use cases. We also brought, our stuff to the table. So our network and service orchestration platform called the Ensemble Service Orchestrator. We brought our carrier Ethernet VNF, Ensemble carrier Ethernet VNF, which provides a software-based layer 2 networking solution. So virtualized NID and accelerated vSwitch. And then we also have a hardware platform that's called the 65 VSE, which stands for Virtual Service Edge. And it's essentially the same capability as the standard white box, the commercial off-the-shelf box. We added a little bit of telco hardening to it, wireless backup, things like that. So, but the processing capabilities are essentially the same as the standard COTS box. And then we had 2 VNF partners. One was Brocade, so we used their 600 Viata router. And then Spirent provided their test center virtual VNF, as well as just the external physical test drivers that drove the 2.1 gig ports, and also did the measurements of the various things that we wanted to show kind of at the end of the test. So that was kind of the operating environment for running the test. Just a couple more comments on that is we had several test goals around this, and that we wanted to have, again, this real world of testing environment. So we brought our pure play kind of virtualization capability with our software carrier Ethernet function, and then being able to run a real world traffic mix. So we tested, traffic scenarios from, kind of worst case scenario of 2 gigs of 64 byte packets, all the way up through, the top level 15, 18, or whatever the top level frame size is, and then, several in between. The results that we'll focus on in the report are going to be around IMIX. So, what's a standard internet mix of traffic, and what's the performance envelope. But we wanted to characterize each of the steps from worst case to best case. Also, again, as I mentioned, we're not running a single VNF environment. This is a multi-vendor, multi-VNF service chain, which is really what the carrier customers that we're talking to want to see. If you're looking at TCO and ROI, NFV has to be able to displace multiple physical appliances, right? So I can't have one VNF on one box. I have to have one low-cost box that's running multiple VNFs for multiple partners all in a service chain, and still deliver that high throughput, low latency, no packet loss. So we really wanted to see that. And in terms of those measurements, some of the other reports that we've seen have really focused strictly on throughput. And while we agree throughput is very important, you can't have high throughput with a measurable amount of packet loss or packet reordering or high latency or jitter. And so we wanted to measure all those things, right? So it's throughput, loss, latency, jitter, delay. All of those characteristics were measured because, again, in a real world scenario, your layer 4 to layer 7 applications have to have a solid networking connection to work properly. So that's really what we wanted to see in terms of our test objectives. So we had a test environment that was running, multiple VNFs again. I want to emphasize that it was running on that one common hardware platform, the white box Intel, Atom C2000 processor. And we did different test configurations. So we ran our ECE VNF by itself and the whole performance envelope with that. And then we were able to instantiate multiple additional VNFs and put them in a serial chain. So, routers and so on and so forth, all chained together in series on top of our accelerated vSwitch and VNID software platform, and then again run the whole traffic profile and characterize the performance envelope across those different scenarios. So in a nutshell, that was the testing that we did over the course of the week. Lots of different configurations, both on the COTS as well as our own internal hardware platform. And then we've got a fairly lengthy report of detailed raw results that we're going through right now. So I think, as Deb mentioned, we're trying to get through all the details,
sure.
summary together and all that stuff. So that's kind of where we were. I'll just kind of flip here to the slide that I've got. I guess we'll send you the slides offline. But
sure.
So when we look at the actual results, again, hopefully, by the beginning of next week, we'll have, approval to show the full table results. The stuff that we had in the slides that we have here today really just show our ECE performance. It's actually kind of boring because it's across the entire, traffic, portfolio. It's 100% line rate, no loss, very low latency. So, yay us. It worked the way we had hoped it would work. But, when we kind of got to the summary and what we talk about in our press release, the punchline is that, even in a multi-vendor, multi-VNF service chain, when we look at an IMIX traffic profile, we're still able to support 2 gig line rate, throughput with no packet loss and extremely low latency in that multi-vendor, multi-VNF service chain. And so that's really what we wanted to see. Now as we got to 4 VNFs in a chain and kind of reaching the limits of the physical hardware, in that C2000 box, we definitely see some things, the lower frame rates, smaller frame rates, obviously you get some less than line rate throughput. We're looking at the details of all that, how we may want to optimize at some point in the future. But the interesting thing is, the important thing is that there's no pre-development for this test. I mean, we really kind of decided rather late in the game that we wanted to run the test. So this is a test on a COTS box that you can buy online with our stuff, Brocade stuff, Spirent stuff, straight off the shelf. They're onboarded into our ecosystem, so they can be orchestrated with our service orchestrator. But there was no other special tuning or optimization done. So, we got these really good performance results, which is kind of a straight off the shelf type of software capability. So, as we look at some of those edge cases of performance, we'll look at what other potential optimizations we might want to do, with our ecosystem partners around specific use cases like VCPE, and then, targeting specific customers. So from that standpoint, we were very pleased with the results. It's exciting for us because, again, kind of going back to our tagline of making NFV real, real world test cases, real world, traffic profiles, real world hardware that's going to be deployed. We were able to validate, unequivocally that the performance is there, at a reasonable cost point, in a multi-vendor environment. And the fact that we can do all this in software means that we can we can orchestrate it centrally. So it's central management, automation, we can validate TCO and ROI beyond even the potential CapEx benefits of NFV, and then get into, operational streamlining. As I mentioned earlier, we're talking about working with a number of different customers in proofs of concept and actual live trials. And so, as we talk about the TCO model with them, we're looking at scenarios where we could do like zero touch deployment of a box. So, one customer that we're doing with has got an enterprise in a box type of solution that they want to do for retail. So, if I can FedEx a box to a retail site and really, they don't have to have any special knowledge there except to take the box, put it in the closet, add power to it, plug in a cable, and then off it goes. It'll phone home. We could do it wirelessly, even with the wireless backup connection. download the ECE image, get that configured, put the VNFs on top of it, and get that all set up. Not only do you not have to do a truck roll to put a box in, you don't have to do any configuration. So there's OpEx benefits as well in terms of the TCO that we want to prove out, again, in those VCP types of solutions. And, again, it's all running on that, kind of low end, box with good performance. So we're very excited about the results. We're looking to do some additional tests with our partners and try some additional configurations in the future. But as far as a first test goes, we're quite pleased.
Yeah, I mean, it sounds like you guys, like you said, kind of really did it all you could to make this as real world as possible at this point. Because obviously, you don't want to go into someone's network and actually try this on a live network per se. But with the partners involved, the equipment involved, it sounds like you guys really tried to make as much as you could at this point in time what you could actually do out there.
Absolutely, yeah, and just to clarify one point, I mean, we wanted to do this with a third-party test house because, again, we wanted no question around the test results or how the test was done. So I mean, we commissioned a third party to go do this, and so from that standpoint, it's going to be good feedback for us, both from learning, but hopefully also from a PR perspective.
Yeah.
We are also doing, as I mentioned, a number of live trials with customers. Now, those are around specific sets of requirements, and the good thing is we'll be able to bounce what we've done off in this third-party test house with what we've seen actually live in a customer environment. And we want to supplement this report that we'll get from the third-party testing authority with some case studies, some genericized case studies that we'll do with lessons learned from some of these customers. And we kind of put more context and meat behind, again, making NFV real around these specific set of use cases, with these types of customers, wireless customers, wholesale customers, what other customers, CLACs, so on and so forth. So, from that standpoint, we're triangulating, a lot of different sources into, being able to show that, NFV adds value, can do it in a cost-effective manner, that there's operational benefits, there's potential competitive, time to market benefits with it, and we can actually quantify that with, real throughput numbers, with real TCO numbers, and bring all those things together. So that's, a little bit later tying all those things together, but those are the other activities that we're involved with right now.
Got it. Okay. And obviously, like you said too, it seemed like from the results that you guys got back, for the most part, everything looked 100%. Everything looked good. I mean, it seemed like, obviously, like you're saying, as you kind of maybe stack more and more stuff on this, perhaps you might get a little bit of issues down the road there. But at least for now, it seemed like from what you guys saw, at least initially, the results pretty positive.
Yeah, absolutely. From everything that we expected within the multi VNF environment, it did what we wanted. And even in places where, we were kind of getting out to the edge of the performance envelope of the box that we were running on, we were sub-line rate throughput on some of those cases, but there was still no packet loss. And from the standpoint of the requirements that we would need for a VCPE type of solution, we're 95th percentile is 100 meg or less type of connection. We're still, several times above that in terms of throughput, and latency, good latency and all those things for those types of applications. So we didn't run any tests across the performance envelope that would not allow us to go into a VCP type of environment with, many VNFs in a chain. So, and all running on one box.
Got it. Okay. Got it. How important is it, I guess, at this time in the whole NFV development phase to have something like this to show? Because it does seem like there's been a lot of POCs going on, a lot of talk, a lot of hype around what NFV could eventually do. Obviously the business case is a whole different issue there as well. But it seems like, I guess, how important was it at this juncture to really go now to be able to go to your customers and carrier customers and say, hey, this is what we've got. Here's some numbers here. Actually show this. How important is that? I guess maybe for the whole NFV market really to have something like this really to show right now.
Absolutely. No, I mean, and that was one of the reasons why we did it. I mean, we think this is critically important to do because you're right. I mean, you get to the point where you get into POC burnout. There's only so many proofs of concept, and a lot of them have been more generic types of technology validations. And so I think one of the key linchpins to moving out of generic technology validations into actual live deployments. And you're not going to have any carriers that are just going to deploy NFV technology in a greenfield type of environment. I mean, it's going to go in a hybrid type of deployment, or they're going to carve out a particular set of services. And so, we're really looking at applications of NFV and SDN technology around specific business challenges within our customer base, and then demonstrate that, here's proof, here's actual life proof that you can get the quality that you need out of a software-based application on a low-cost generic processor and deliver good quality services. And I can orchestrate it and all those other values of operational automation with NFV to really give you a good TCO. And then, like I said, we're also doing, a thorough TCO modeling activity and some other case studies around different use cases and really trying to bring the whole story together, but having real numbers that you can go to the market with and have a third party with a carrier, standing behind them saying that, yes, look, there's real numbers that show that it's real. And it's not only real from a technology perspective, but it's real from a cost benefit perspective. And so, yeah, I mean, we're hoping to eke the benefit out of it, as a company, for what we did. But in general, as part of the industry, I think things like this, like the Cisco VNI and those types of things, I mean, those are all, industry accepted, value, drivers to moving, things forward. And we hope this type of thing will serve a similar type of purpose around those use cases. So.
Yeah, it should be interesting. Well, again, I know when you guys send me along the information, I'm sure there'll be a lot of stuff in there that I have no idea what it means, but I will take your guys' word for it. That looks really good. But it sounds like, again, like it was a very successful thing. And again, it does seem like at this time, it's pretty important to have something like this out there because, you get the carriers and the operators talking about their certain time frames that they're looking at doing. And, you still see all these POCs going on. You wonder when that jump's going to be between a POC and an actual deployment. And it seems like we're getting these bridges now that maybe start showing those actual, we can actually start doing this here at some point. In the next decade or so.
Hopefully it's quicker than that. But no, yeah, again, I agree. We're extremely excited about the result. And I mean, we're to the point now where we're, around a specific set of use cases that have enough, traction behind them that, we believe that we'll be, taking these things to market in a general production type of environment, this calendar year. That's really what we're shooting for is to start rolling out some of these use cases. And so, again, having these performance numbers that continue to lower the threshold on any concerns that might be, around deploying this technology just, continues to make people more comfortable with the fact that, yeah, it's going to work.